So we have the date at the top of our notes. We have the general topic at the top of our notes. And I've given you 4 X and Y axes on which to draw parent functions today, right? So the first one we're going to talk about is this one. Was that even on our worksheet? No. That's because it's a constant. The equation would be y equals x. It's a horizontal line. Okay? That's why it's y equals x, because it's crossing the y equals 1. It's crossing the y-axis at 1. Correct? Okay? What about this one? That's linear. And somebody tell me the equation. Y equals x. What's this one? What's it called? Perfect. And what's the equation? Excellent. And then we have, last but not least, that one. It is called a parabola when we graph it. What's the name of the equation? Quadratic. Good. Y equals x squared. What does transformations mean? What's it mean? So here's what I heard. So moving the parent function, right? We're moving it around somehow. We're changing it. Isn't that what transformation means in general? Right? Like if you looked up in the dictionary, it's probably going to talk about some sort of change, right? So today we need to make sure that we understand how we're changing it based on where the number that's being inputted into this equation is. Okay? Is it in the front? Is it in the back? Is it a multiplier? Is it being added or subtracted? Is it a negative? All those kind of things are what we're going to have to talk about. Here's the thing about this general transformations lesson though. After I talk to you generally about the transformations, we're going to do almost the same lesson every single time, like 8 or 9 more times throughout the year. Because yes, we'll talk generally about these things, but when we get to quadratics, we're going to talk about all these things specifically in relation to quadratics to make sure you remember and understand how you transform a quadratic equation from its parent. And then we'll talk about it again when we get to cubic. And then talk about it again when we get to square root and cube root and rational and so on. Okay? So by the time we get to the 3rd or 4th time, you guys should be really good at this, right? So I would recommend that we get really good at it now so that when we get to the first time, you're like, oh, I got this. You don't have to worry about it. I know I'm going to get 100 on this. No biggie. Okay? Even more importantly, you know you have the concept. Is that fair? So, what happens if I say, we're going to start here with absolute value. I'm going to give you an example. Y equals the absolute value of x plus 4. How do you think the graph of this function is going to change compared to the original parent function? It'll move up 4. Why do you think it'll move up 4? It's a change in the y values, right? So one way to think about it is this. Where is this 4 in relation to the function? Is it inside the function or is it outside the function? Let me show you this. Y equals the absolute value of x plus 4. Now can you tell me if this 4 is inside the function or outside the function? It's outside, right? This is what inside would look like. Outside the function is going to cause a vertical change. Anything being added or subtracted, even multiplied, is going to cause a vertical change. But if it's outside and it's being added, what he said was that it was going to move up 4. I agreed, but now I have to correct his vocabulary. Are you okay with that? So we're going to say this causes a vertical shift up 4. Isn't that what he said? But isn't this a little bit more mathy? This is using the correct vocabulary for the Algebra 2. You got it? So I have to take just a quick moment and talk about something a bit comical, but also serious at the same time. Okay? I'm addressing it now because it has happened in the past. That's why rules are made, right? Because things have happened in the past, we have to make rules for it. Okay? So first of all, look at this word vertical. It is not spelled V-E-R-T-I-C-L-E. Okay? So just work on your spelling. Make sure you're spelling vertical correctly. The other thing, and probably more important, is that this word right here has an F. And if you leave the F out, it's a totally different word. It really is a different word, isn't it? How awful would it be if on a test you wrote vertical shift and accidentally left the F out of your answer on a test? Guys, I could get it out right now. It's in that stack right there. I keep it because it was funny. For real. I'm not making it up. For real. Someone put that as their answer on a test. I am 100% confident that this particular child did not mean to do that, because when I brought it to her attention, she was immediately as red as Tanner's shirt. Immediately. Completely and totally embarrassed she was. Okay? So it's really very important that we remember our F in this word. Because otherwise, a vertical that means a whole different thing than a vertical shift. Okay? Got it? I know it's silly, but it's happened, so I just wanted to make sure you understood. Okay? So what do you think would happen if I had y equals absolute value of x minus 4? Vertical shift down 4, right? So what's going to happen here? We said this is outside, so it causes a vertical change. In this case, a vertical shift, right? What's going to happen when it's inside?
Would it move horizontal?
It would. It would be horizontal. But here's the thing about it. I'm gonna tell you the way I remember it, if that helps, and then I'm going to show you the technical reason that this is true. Is that okay? The horizontal changes are going to be opposite of what you think. What direction do you think this should move horizontally? To the right. That's what you think, right? It doesn't. It moves to the left. It moves opposite of what you think. Why is a very good question. Can I show you? When you're writing the general form of absolute value, the horizontal change looks like this, x minus h. So if I say x minus 4, what's the actual value of h? X is part of the formula, minus is part of the formula. The actual value of h is 4, so this is going to be a horizontal shift to the right, 4, because the value of h is 4. But if it's x plus 4, that's going to move to the left, because if I make it back to the x minus part of the formula, that has to be a minus a negative 4, which makes it plus 4, right? The x and the minus are part of the general equation. What's the value of h? Negative 4. So that would move to the left. So horizontal changes are going to be opposite or different of what you think. Vertical changes are exactly what you think. This says plus 4, you know you're going to move up 4. This inside, a horizontal change, is going to be different than what you think. It is a horizontal shift. Which direction? Left 4. Any questions? What about then if I say y equals x squared minus 3? What kind of transformation is that going to be compared to its parent? Sorry. Say that one more time, please. Vertical changes are what you think they should be. So it says -3, so you're going to move down 3. What direction is this going to move? So horizontal, shift, right, 5. Do you guys like to be tricked when it comes to math? No, you don't, do you? Okay? So I'm telling you right now, this next part could be if you let it. I'm asking you not to let it. Okay? But in the meantime, I'm going to try to see if I can trick you. But you're going to fight against it and not let it. Not actual fighting, please, but in your brain. Okay? What kind of change is this? Vertical? Why is it a vertical? Because it's outside the function, right? So up to. What kind of a change is this? Vertical, is it? Or is it inside? It's horizontal because it's inside, right? Which direction? Left. 2. I'm going to graph this for you. First of all, here's my parent. Y equals x. Here is y equals x plus 2. What's going to happen, you think? It's going to go up 2. Did it? Yes. Okay. Now I'm going to put another equation there. I'm going to leave the first 2 equations in there, and I'm going to put another equation in there that is parentheses x plus 2. Where should it go? Left 2. Did it go up 2 or did it go left 2? Yes. Yes is the answer. Okay? Linear functions sometimes get confusing when you do transformations. And in fact, if all I gave you this first one and then the second one without any equations, could you tell me exactly what the equation was? No, you could not. You couldn't tell me if they wanted it this way or this way. Okay? So some conversation or communication has to happen there, right? Don't let yourself, please don't let yourself be confused by linear functions. Okay? Because of all the functions we're going to talk about, linear is not even close to the hardest. All right? Now, let me make something clear to you. For a constant, if I say y equals 3, it moved up what? 2. Why did it move up 2? Because it started at 1. So this would be a vertical shift up 2. Does everybody understand that? Okay. So is that the only kind of transformations we could have? Things being added or subtracted? What else could we have? Multiplying and dividing, right? What if we have multiplying and dividing? Well, let's talk about that real quick. What if I have, different color, y equals 2 absolute value of x compared to y equals 1/2 absolute value of x. These are the two that I want to talk about. Okay? So we're going to actually look at these visually. The parent is right here. One of these values is greater than 1, and one of these values is what? Now we can start by saying less than 1, okay? But we're only talking about positive values right here, because a negative, we're not to that yet, okay? We can either have values that are greater than 1 or values that are between 0 and 1. Are you okay with that? Some people are like, oh, so fractions. Well, guys, isn't 4/3 a fraction? But is 4/3 between 0 and 1? No, so that's why I was real specific, okay? Real specific about what we're talking about. We're talking about something that's greater than 1, or we're talking about something that's between 0 and 1, okay? Where is it in relation to the function? Outside. If it's outside, it's going to cause a vertical change. Are you okay with that? So what we talked about over here, all these were vertical changes because they were outside of the function, right? So if it's outside, it causes a vertical change. But it's not a shift this time, is it? Okay, do you remember what it is? You remember any transformation words besides shift? Good guess. Rotation is really more geometry stuff, but that's okay. Good guess. Reflection we'll get to in just a second. A vertical stretch. Okay? This is a vertical stretch. You remember that? When we talk about a vertical stretch, we talk about it being by a factor of. Okay? This is a vertical stretch by a factor of what? 2, because that's the multiplier. So if I make it a vertical stretch, it's like I'm holding on to the end of the absolute value and stretching it this way, which is going to make it taller, like that. What's gonna happen if I have a number between 0 and 1 then? It's going to be a vertical what? There's 2 different words that you can use. The one I use most often is compression. Okay? Another word that sometimes is used, though, is shrink. Stretch and shrink, stretch and compression. Okay? By what factor? Whatever the multiplier is. What does its graph look like? If I hold on to here and compress it, what's going to happen? It's going to squash, so it's going to be half as tall as it was before. Any questions about that? So what happens? Oops. For this. Where is the multiplier? Inside, which implies that it's going to be what kind of change? Horizontal. What did we talk about a second ago if it's horizontal? If it's horizontal, it's going to be different than what you think, right? So this is a 2. This is greater than 1. So it's going to be a horizontal. You think it's going to be a stretch because it's greater than 1, but it's inside, so it's different than what you think. I just wrote something wrong. Can I fix it? Why is it a horizontal compression by a factor of a half? How is that related to this number right here? Reciprocal. Okay. Look at this one then. Tell me. Horizontal what? By what factor? Uh-huh. Reflection is the only thing we didn't get to. Reflection, what do you think causes a reflection? A negative in the front. Okay? If it says y equals negative absolute value of x, the parent looks like this. The actual function looks like this. Okay? Any questions about that? Have a great day.